Okay, so let's look over this review for reassessment on limits, continuity, and the intermediate value theorem. So here we have a series of questions that deals with finding the limit if it exists. So we look to this first problem and we say, hey, this is a limit as x approaches -1. All right, and if we look at what we're provided and it's something that we can factor, a lot of times if we don't have a calculator, but we can factor our expression, what we're able to do is make it a little bit easier for us to evaluate. So for this first example, we can factor the numerator as x plus 1 times x plus 5. We can factor the denominator as x minus 4 times x plus 1. Right? And so we notice that if we're going to substitute in -1, my numerator is going to go to 0, my denominator is going to go to 0. But in this factored form, it's easy to see that I'll have a common factor that I'll be able to cancel in the numerator and the denominator. So now my limit, right, is going to be what I get if I substitute in that -1, which would be -1 plus 5 divided by -1 minus 4. Right? So this would end up equaling 4 over -5, or in other words, -4/5. Okay. For number 2, we get a similar look, and once again, if there's something that we can factor, it makes it easier for us to evaluate if we factor first, right? So we can say, hey, let me factor, and I have 4 minus t squared, and this is all over t squared minus 4. And I can tell now if I substitute in -2, the numerator goes to 0, the denominator goes to 0. So I'm going to try factoring again. Right? And I'm going to factor one more time, so I'm going to have t times, not 4, times 2 minus t, 2 plus t because of my difference of two squares. And then I'm going to have t minus 2 and t plus 2. All right? So now if I look at my situation, if I substitute in that -2, yes, I have the 0 term here and the 0 term there when I substitute in -2, but they're common. T plus 2 and 2 plus t are common factors, so then I can cancel, right? And so therefore, now when I substitute in -2, I'm going to have, right, -2 times 2 plus 2 all over -2 minus 2, which is going to give me, let's see, 4 times -2. That's going to be a -8 over a -4. All right, so that's -8 over -4. So I know that then my final answer is going to be 2. All right, and it does help to box your answers. Okay, so if we look to the next examples, here I have a limit as I go to infinity. All right. When I have a limit that goes to infinity, I want to look to see where my highest powers are. So in the numerator, my highest power is x cubed. In the denominator, my highest power is x cubed as well. Right? So when the powers are both the same, you look to the ratio of the coefficients, right? And there is an implied coefficient of 1 on the x cubed in the numerator. So I'm going to have -1 over 2. Right? There is mathematics involved in why this works, but for our purposes, we can look to the powers, right, and then look at the ratio of the coefficients when my x is approaching an infinity. Okay. If I look at number 4, here I have the variable t, but it's only approaching -3. So for this one, if I substitute, right, in the numerator, I'm going to have 9 plus 9, right? So in the numerator, I'm going to have 9. And in the denominator, if I substitute in -3, I'm going to have 9 plus 9 plus 3, it looks like. All right, then I'm going to have 9 plus 9 in the numerator, and I'm going to have 9 plus 3 in the denominator. So I'm able to evaluate this directly, and that's going to be 18 over 21. Right? And unless you're told to simplify, right, 18 over 21 is a perfectly valid answer. Okay. For number 5 here, if we look at our question, notice once again that here we are approaching an infinity. And if I look to my highest powers of x, my highest power is bigger on bottom, so that means that my limit will be 0 as I approach an infinity. And lastly, I have another limit that involves an infinity. This one happens to be approaching positive infinity. And if I look here at my highest power in the numerator is x cubed. In the denominator, it's x squared. So I'm having bigger on top. So I'm going to have no horizontal asymptote. Right? Therefore, I know I'm going to either have a plus infinity or minus infinity. And I need to work to figure out what it's going to be. So if I look to this, I have a positive number cubed. So that's going to be negative times a positive cubed. And in the denominator, I'm going to have a positive number squared. Right? And so what that gives me then is a negative times a positive. So that's going to be a negative in the numerator, a positive in the denominator. So I know my result is going to be a negative infinity. So that is examples of given a function finding limits, right? We can talk about factoring if we get solutions or if we get situations that give me 0 divided by 0. We can look at direct substitution that we get a value. We can look at what happens when the power in the numerator and the denominator are both the same. We can look at what happens when the power in the numerator and denominator is bigger on the bottom or bigger in the denominator, and what happens when the power is bigger on top or bigger in that numerator. Okay? In the videos that follow, we will discuss the other problems.